Look at the stars, son. Can you find the Big Dipper?
Okay, so I start by finding the North Star.
Did you know that our sun is just like all the other stars in the sky?
Really? That's so cool!
And this Earth we are on is one of the 8 planets orbiting the sun.
What does orbiting mean?
Orbiting means that our planet is circling around the sun.
Hmm,
To understand how this entire system works, you have to understand how stars are formed.
okay.
A star begins as a part of something that scientists call a stellar nursery. A stellar nursery is a cloud of dust, ash, gas, and electrons. All the materials, including elements in the stellar nursery, came from previous supernovae and planetary nebulae. There are no stars in a stellar nursery. These nurseries are enormous and can be hit by shock waves, which cause them to collapse.
What happens next?
As the star collapses, it begins to heat up, and this heat creates energy, the beginnings of a new star. These new stars, protostars, are still mostly clouds of mass with no visible light. These protostars then get so hot that they begin to have ignition or sparks. They are now called main sequence stars. Nuclear fusion begins to take place.
What is nuclear fusion?
Nuclear fusion is when 2 atoms form together to make a bigger atom.
Keep going.
Our sun is a main sequence star, and so are about 90% of the stars in the universe.
Wow, that's amazing.
I agree. So after this point, stars have 2 paths they can go on. If they have a mass that is at least 5 times the size of the sun or more, they will later become supergiants. A supergiant is a star that is beginning to run out of energy. The hydrogen in the core becomes depleted, and the outer layer begins fusion. Elements like beryllium, carbon, and oxygen are formed. The outer atmosphere begins to separate from the middle, and this leads to a supernova. A supernova is a giant explosion. In 1 second, there is the same amount of energy as all of our sun's energy over its entire lifetime.
That's a lot of energy. What does all that energy do?
It sure is, son. During this explosion, elements like gold, lead, and silver are produced. After a supernova, these 3 things can happen. Some of the leftover materials go back into a stellar nursery. For suns with masses 8 to 20 times as big as our sun, neutron stars are formed. These stars are crazy dense. 1 teaspoon weighs 2 tons.
No way.
Yep, and these are called neutron stars because it is so dense even electrons and protons are crushed together, leaving neutrons. If the star was even bigger than that, 25 times the size of our sun, then a black hole is formed.
What's a black hole?
I have gotten way off track here. You wanted to talk about planets, and here I am talking about black holes. You should research black holes, son, because they are fascinating. But we need to go back to the main sequence star. We talked about what can happen to stars that are really big, but don't you want to know what happens to smaller stars like our sun?
Okay, Dad.
Well, as our sun and other smaller stars begin to run out of fuel, they become red giants. These don't have as much energy because most of the hydrogen has been converted to helium. Reactions in the core slow down and the core begins to shrink. The outer layer still has hydrogen, so it starts to grow. Next, the atmosphere separates from the core and a planetary nebula is formed. A planetary nebula is a thin shell of gas that glows because of the white dwarf's energy inside.
What is a white dwarf?
I'm getting there. Hold on. The planetary nebula eventually dissipates. The outer part returns to the stellar nursery while the core becomes a white dwarf. A white dwarf no longer has enough energy for fusion, but it is still hot. After the heat leaves, it becomes a black dwarf.
Okay, so I understand how stars are formed and how they die, but when do planets come into the picture?
Planets are formed in the early stages of a star's life. After the stellar nebula collapses and protostars are formed, there's a lot of debris called asteroids orbiting around the stars. As asteroids collide, they form protoplanets. As these protoplanets collide and combine, they form planetesimals. Planetesimals with more gravity can pull more material toward them, and this results in fewer, larger planets. Eventually, as there is less debris, these planets keep a constant orbit around the sun.
That makes sense, but why are the planets closer to the sun more rocky, while those that are farther away are made of gas and ice?
Great question, son. There are multiple reasons for this, some being that gases close to the sun are used by the sun or blown away by the strong solar wind. This leaves the gases and ice in the outer solar system. Another reason is that the outer planets have a lot more material, as debris often gets pushed outward, and having more material allows them to have more gravity to hold on to more gas.
But what about gases on Earth?
Again, a very good question, son. As I was explaining before, elements are formed during nuclear fusion. For smaller stars, this means only hydrogen and helium. However, for bigger stars, elements like oxygen, beryllium, and many other metals are formed. In our planets, the inner planets tend to have heavier elements like oxygen, carbon, even gold, while the outer planets have lighter gases like hydrogen and helium. This is because there is a frost line in space separating the inner terrestrial planets from the gas giants. Hydrogen compounds, like water, typically condense at low temperatures and remain gaseous inside the frost line, while temperatures are higher. Heavier, rocky, and metallic materials condense at high temperatures, resulting in inner planets made almost entirely of rock and metal.
Wait, but then oxygen wouldn't be on Earth.
Great thought, but this is where comets come into play. Comets, basically balls of ice and dust, come into the inner solar system from the outer system and will occasionally collide with inner planets. When this happens, compounds carried with the comet are now part of the planet and the comet collides with.
Wow, is that a comet that just flew overhead?
Yes, it is.
This space stuff is really cool, but it is a bit hard to grasp.
It sure is, but it isn't hard to look at.
I just found the Big Dipper.
Well done!
Can we come out here tomorrow night?
We sure can.